So image pyramids can be implemented using a method called pyramid Gaussian, which is available in Skykit image.transform. So we'll be using that specific function or specific method for doing this. So if you remember, if you recollect, in post 1 we discussed about image pyramids and sliding windows. So image pyramids, you're just scaling down these images to different smaller scales, so that you because and the windows, and we also saw that the window size could be fixed size window size. With smaller scales, you are able to detect different of these potholes at different scales and different locations. So that's the overall concept of image pyramids. So let's see how that is implemented using this method, pyramid Gaussian. So I'm just taking just one of these images, okay, just one of these images, just to demonstrate to you. You just read the image, and then what you do is you so pyramid Gaussian is the easy method. You give the image and you give how much you have to downscale it. So I've downscaled it to 1.2, a scaling factor of 1.2. So each iteration, it scales down by 1.2, a scale of 1.2. So you can try out with different of these scales, 1.2 or 1.4 or 1.5, and then try it out. So and then we give a special condition saying that this image loop or the scaling down doesn't go below or standard window size. So if the width is less than 80 or depth is less than 40, we don't take that image. So we want those images which is within our window size. So if it is below those, we break it. Okay, so I'm just printing the layer shape, so just to show that, and then showing this. And then showing those images also. Let's just run this. This is only to demonstrate you the different methods of how the image pyramids happen. So so you can see that the size of the images. So this is the original size, 183 by 275. The original size of the image, 275 as the width, and 183 as the height. So for each of this iteration, you can see that the size decreasing, 153, 128, 192, etc., etc. So you see that progressively reducing. So once it is within our window size, we stop it. So 6394 is the last one. So beyond that, it goes beyond below our window size. That's why we've stopped it. So this is the image pyramids. Next, we'll see the sliding window also. So as we said, sliding window is we sliding a fixed size window across the image horizontally and then vertically. So that's the overall sliding window. So again, we read the image, one of those images. We take this window size as 80/40, which is your width and your height. 80 is your width and 40 is your height. Now there's something called step size. The step size is how much you have to move your window each side. So you have 80 as the width. So I'm adopting a step size of half the window size. So you have this window. So next step size, you take half of that this thing, and then you move it. So that you have an overlap of always half of it. So the step size is something which you can also experiment with. You can even take the number of the step size as the complete width of the image. You can take the step size as 80 itself. Only thing is the number of windows which you get, or number of slides which you get, would be much lesser. And if you take a much lower one, you will get much more windows. It will have to run for more of these windows. So you build two iterative loops. One is to do it within the y, and one is for the ranges of x. So for each of this y, so y is the iterative loop, the vertical is the iterative loop. So each position of y, okay, each position of y, we move these X. Then you take one more step, by 40, and then move. Then one more move. So that's what we are doing. So you're just taking a clone of the image, so that, and we just drawing these rectangles on this size based on the window size which you extract, and then showing. Let's run this. So you'll see these based you'll see those windows sliding here. So see, so it's slid half of it, then it's going horizontally, reaching at the edge, and then going vertically, right? So you will see all those, so all sliding across all those images, or all the a complete image. So you have these methods, sliding windows. So that's the sliding window. Next, what we'll do is we have to combine. So when we have to do the object detections, we saw in the post 1 that you have to combine the pyramids and image pyramids and the sliding window. So for each gradual reduction of your images, you do a complete sliding window, so that you detect all those objects which are there everywhere, irrespective of the size. So it becomes size invariant and scale invariant. So when you do it for different sizes of the images and different and you do this window size, you get the size and scale invariant objects, and you will be able to detect all these objects across these images. So that's what we will do. We'll see next. Now, before we get into the actual inference process, which is our object detection on a given image, let's put these image pyramids and sliding windows together, and then just see how this whole function or how this whole process works through some visualization. So here we are now going to predict right now, which we will do during our real object detections. But here we just demonstrating, showing how these two things work together. So what we'll do first is we will wrap this sliding window into a function called sliding window. So it's the same it's the same process which we have the same steps which we have seen earlier in this sliding window. Next we will start a big inner loop, that is to read each of those images. No, I'm just reading just one of those images for demonstration purpose. Reading one of those images, and then first we start the sliding windows, or the pyramids. So first we take you do the pyramids by you give the downscaling factor, and then for each of those the images, which is for each of the scale or each of those layer, we apply the sliding window layer. Okay, we apply this sliding window, and you get the XY coordinates and the window also, using the sliding window. So here you're yielding the X and Y and the images also. Okay, so and then we fix a condition that if the window size is below, or the layers is below the or standard window size, we just go to the next layer. Okay, we don't want any of these layers much lesser than our standard window size. So that's why we've applied this function. So ideally in the whole process, what we do is we do a prediction here. Once we get that the scale and the layer, we do a prediction. But since this is just to demonstrate, we're just taking a clone of that layer, taking a copy of that layer, and then showing a rectangle to show the process. So let's run this. It will take some time to run this. So what it will do is it will take each of the image, progressively scale it down, and for each scale down version or the image, you do all this movement of these windows, and that process continues. So it will, based on the speed of the image, it will take its own time. So you can see the outputs here. So for each of those image, you have this window size moving. moving across, and as the size of the image progressively gets smaller, you can see the window size also relatively getting bigger, because you see the relative size bigger because the scale of the image by applying the pyramids has become large. When you go downwards, you can see much larger window size. See, the window size is actually becoming relatively bigger. It's not getting bigger, the image is actually getting smaller. The window size is the same, but the image is getting smaller, and so you get the impression that the window size is getting bigger. Okay, so you can see that window size is actually getting smaller, or I'm sorry, the image size is actually getting smaller. Let's see. So this is still running. I think it's come to an end. So see, you can see how the window size relatively becomes bigger as the size of the image is getting. So this is how we detect images. So or detect different objects at different scales. You will get to see different of these images or different of these objects. You get to detect by reducing the scale. So so that's the overall concept behind image pyramids and sliding window. Now we'll use these, what we have demonstrated this, to actually predict and get different bounding boxes for for the object which we want to detect, which is the potholes. And that's what we'll do. We'll see next, the real object detection inference.